So, okay, so you got these algebra tiles. So take out get one of these big squares that you got there on the algebra tile. So just take it out and you can draw it on your piece of paper, on your notebook. Draw the square, maybe. Because it says right here you have an x squared. An x squared is this right here. This right here is an x squared. Why is it an x squared? Let's see. So it's this yellow one right here. You have it. It's positive. It says positive here in the front. It says positive. So if it's a square, is that for any, the definition of a square is that, say I know the length here is 3, and it is a square, then it has right angles, no? Right angles here, right angles. And so, what would be the length right here? What would it be? 3. By definition, no? This is as basic as we can get. A square is because it has all the sides are the same length, no? So it'd be 3 times 3. You don't have to be writing that down. But in general, whatever it is on the side here, whatever x length that is, okay, if this is a length of x, then what's the length of going up and down? X. And to find an area, because that's the area inside, we would be x times x. And x times x is what? X squared. So that is an x squared, and we have one of them. So I have 1x squared. So I have one of them. It describes how many you have. Say I change this, and I say that I have, instead of an x squared, I have a 2x squared. Then what do I have? I have another one. I have another one exactly like that here, because you got 2 of them like that. Yes? Okay. So that's kind of like the idea of using these algebra tiles to do this problem. Okay, so now I got 4 x's. What is x? 4 x's? Well, that's when you have those little sticks, those little algebra sticks. Why? Because it has a length of x. You would have a length of x with a width of 1. So x times 1 is x. So these other ones you have there, if you want to take one out, just, I don't know, just to see what they look like. And that is called a x. This is an x. So a stick is an x. And so we have how many sticks? How many sticks do we have? We got 4 sticks. If you want to, because we do have a lot of time today for one lesson, you can go ahead and take out a stick. Each one of you guys take out a square and take out a stick and draw those on your notebook. Draw the square, and what we're gonna do is that this is called complete the square. Is because we want to continue on making a square by adding these sticks and little units that we're gonna have. So we're gonna complete the square. So how am I gonna complete the square? Well, look, these little sticks, I can go ahead and put a stick here, which will be an x. Don't do what I'm doing, but like I could put one there, I could put one here, and I don't know why would I do that. I put it here and put one here. And actually, why not? Oh, you might complete the square. Oh, you might make another square. What the heck? It actually could. Because all I could do is just add the little tiny ones here. But I'm not going to do that because I've never done it like that. But you can see that you got the little ones there. You can take a stick and take a little one, a little tiny one. And that little tiny one could actually fit right here. And it'll keep us, make a square. Oh my God, I did not know that. Well, I did not never done it like this. So it would be a square. It makes a square. And it would be, but but I'm going to have extra. See what's going on here? See what's going on here is that I do have an x squared, which is this yellow one. This is an x squared. I have 4 x's, which is 4 sticks, which would be 1, 2, 3, and 4. And I have 10 little tiny ones though. That's the problem. I got 10 of these, and now I only need 1, 2, 3, 4. I need only 4. I got a problem. So what I'm gonna do is this. Watch. I just want to complete the squared, and I only need 4 sticks. 4 little tiny ones. So what I'm gonna do is I'm going to just like subtract 6 of these little tiny ones that I have here. They're extra. I'm gonna move them to the other side. Because what I really need, I only need 4 little tiny squares. Little tiny ones. Another way to do it, you know what, let me just regress a little bit, but the way I teach it is a little bit different. I just came up with this. But let me go back to the idea, no? So I got these, I got those sticks, and the best way to put the sticks right next to the x squared is to put 2 of them there, and then 2 of them here. So I got 4 sticks, which is this 4 sticks. And I only need 4 little tiny squares. It's another form of putting them down there. All right, I only need 4. So I got extra, I have to get rid of 6 of them. And let's continue on then. So this is gonna go like this. So we're gonna go what? X squared plus 4x. And what is 10 minus 6? That's gonna be 4, and that is equal to negative 6. And now I can do the x here. Let's do the x now to this. Let's do an x. What goes at the bottom of the x? 4. What goes on top? And what are 2 numbers that multiply to 4? Add up to 4. That'd be 2 and 2, isn't it? Which makes sense visually. If you want to see it over here visually, watch. I already told you guys, we already said that this is x, and this is x, and then the x times x is x squared. And then I got this is x times 1, so this is a plus 1 here, plus 1, and this is plus 1, which is x plus 2. So this would be x plus 2 times, this is x plus 2. The whole thing, x plus 2. I don't know how to do parentheses around that. All right, x plus 2 times x plus 2. Well, here mathematically would be what? Again, doing it the way I've been showing you to do factoring, it would be what? Well, how do we write down the answer to this? X plus 2 times what? And then equals what? Negative 6. Yes? So far? Making sense? So what is x plus 2 times x plus 2? Is there another way of writing x plus 2 times x plus 2? Wouldn't it be x plus 2 squared? Wasn't that one of the questions that I had done also last time about solving equations? That you can just go ahead and get rid of what? Get rid of that 2 by doing what? What's the inverse operation of doing? Square rooting it? Yes, square rooting it. Square rooting it. So this cancels out. So I am going to have here on the left x plus 2 equals. And every time you take a square root of an equation on both sides, you have to do a plus or minus on the right side here. Whenever you take a square root, that'll be square root plus or minus square root of negative 6. Leave that alone. Don't worry about that square root of negative 6. How do I get the x by itself finally? Subtract 2. So x is going to equal to negative 2 plus or minus square root of negative 6. that is the answer to this. So we're getting to more complicated solutions here of quadratics, and completing the square is one of the ways to solve these complicated equations. Let's see, what do we got here? Let's see here. In reality, let me show you, that's like the thought process of it. But the way it's taught, and I'll go back to the way it's taught in YouTube videos or whatever, and all these, and probably the way I was taught, maybe, if I remember. The way I was taught with completing the square goes this way, okay? Listen, I'm gonna go like this. The procedure goes like this. If it's not factorable, you want to leave the x's by themselves on the left side and just get rid of this whole thing. Like, don't even worry about it, just subtract the whole thing. That's the way it's done, no? The procedural way. And then this is going to be -10. That's the way it's done. And then we do this b over 2 squared. The way you get this number here to complete the square, you're going to go b over 2 squared, where this is a is 1, b is 4. So b is 4. So it's going to be what? 4 divided by 2 squared. What's 4 divided by 2? 2 squared. So that's how you get this number. See, without everything I already showed you visually how it works. But this procedural. Then again, you want to do the x, go ahead and do the x. But most of the time it will turn out to be like this. A quantity squared, and it's going to be x, and the square root of 4 is 2, plus 2 is equal to -10 plus 4 is -6. You square root it. You get x plus 2 equals, because it's a square root of plus or minus square root of -6. And then just move it over. This is the procedural way to do it. -2 plus or minus square root of -6. So that's procedural way. All right. Who remembers doing this in algebra 1? No? Nobody? Let's try and do one now by yourself. I'm going to give you one. You know what? Let's do this one together. The way I want you to do it. The procedural way is the best. All right, let's go. Number 2. How to do this. We do have enough time, so here's problem number 2. You don't want to have 2 big x squares, because as it is right now, you would have to draw 2x squared if you want to do it with the algebra tile. You would want to do this and then try to figure out how to put the other little sticks on the sides and all that kind of stuff. We're not doing that anymore. We're not doing that. All right. So we're just going to go to the procedural way. So procedural way is to just have an x squared by 1, not 2, but 1. So how do I get rid of this 2? Divide everything by 2. Divide everything by 2. So we're just doing a trick, and it's an equation, it's fine. So 2 divided by 2 cancels out. It's going to be x squared, and then -6x, and then equals, and I'm already going to leave space because I'm going to complete the square. 10. Then we're going to do that b over 2. That's how it works. If you really want to see it, actually, I will do it right now. I will draw it. I have it over there. Let's draw it again. But it's not necessary, but you'll see it. So we got a x squared, got a big. Now, how many sticks do I have? 6 sticks. And they should be what? Red. They're negative, no? The yellow is positive, red is negative. So the way to draw them is to put half of them on the right side and half under. So how many little tiny little squares do I need to complete that square? I already hear people saying it. To complete and make it a square, how many little tiny ones do I need? Don't I just go like this and like this? That looks like tic-tac-toe. That looks like 9. Yes? So, and again, see, this is visually. This is like, I mean, that's what it means. And to do it here, you just do this b over 2 squared, because you don't want to be doing that. That's like how it's taught in like elementary, middle school, and whatever, algebra 1. But you want to get to this more abstract. This is called abstract. This is more visual. You got b is what? What is b? -6. Even if you mess up and don't put the negative, it's still going to be fine. What's the -6 divided by 2 is what? 3. 3 squared is? Okay, it's 9 because that's what right here. 9. Yes? Everybody good? 9? So what am I going to put? It's always going to be a positive number, plus 9. And what you do to one side, what? You do to the other side, so I'm going to go plus 9. If you want to continue on, it's okay. Do your x. And what goes at the bottom? What was at the bottom? -6. What goes on top? 9. And what are two numbers that multiply equal 9 add up to -6? -3 and -3. Why? And it makes sense as to this. Look, -1. This is -1, -1 because it's red. This is -1, -1, -1. So it's really -3 here, and I got -3 here, and I got -3. Negative times a negative is a positive 9. So it's positive. Yes? So this is going to be then -3 times -3. So what is the factors? How do I write that? Write it down right here. X minus 3 squared, if we're going to skip that step, but it is going to be x minus 3 times x minus 3, no? Which is going to be x minus 3 squared. And we got what? 10 plus 9 is what? 19? And then we do what? What is it called? Square root it. Square root it. What's then the square root of 19 is just we don't know what that is. I mean, some decimal. And finally, what do? Add 3. So x is equal to what? 3 plus or minus square root of 19. So that's the lesson for today. Let's see. Okay, let's try one a little more difficult. Yeah, let me give you like good amount of time here to do this one. And for the video, this is it. See you next time. That's it. Stop.